So we're going to talk about radians. Now, you know degrees. Okay? So degrees is very limited in what it can measure. Okay? Because it's an angular measurement. So when you're talking about angular velocity, angular momentum, that sort of stuff, when you're measuring things that are going in circles, degrees works quite nicely. All right? But the problem is that we need a linear measurement. Okay? And that's what a radian's all about. So some bright spark decided that we can measure things by using the radius of the circle as a linear measurement. Okay? So if you look at the diagram that we've got on the board, you can see that we've got a circle. Okay? And we've got the radius of that length there. So we'll call the radius R. I know I'm really original. We're going to call the radius of that circle R. By definition, if the length of the arc, right, so that's that length there, if that length of that arc there is also equal to R, then the angle in the middle is equal to 1 radian. By definition. Now, by definition, every single thing we've ever measured or unit that we've ever used has to be defined. Right? In the world, over in Paris, there are blocks and rods and other things that determine how long a metre is. So a metre is defined to be a particular length. We know that it's approximately that. We know that a kilogram, there's a certain block. They used to use blocks, now they use other calculations. But there's a block of substance that is defined to be 1 kilo. And every measure that we've got a kilo from comes from that block. Okay? Now, a radian is just another unit. Okay? And we're going to be using radians to help us do some calculations. Alright? So, how do we define it? Well, what I would like you to do is for you guys to have a think about how many radians, in other words, how many times can I go round a circle with that length R? Do not call out if you know the answer. I'm just getting ahead of a couple of you. Okay, so for example, that is 1 length R. And I can go again. Okay, now this is not going to be drawn to scale. So there's my second R. Alright? My question to you is how many times can I go round the circle once? So have a think about it. Write down what you reckon your answer is. So how many times can I go round one complete circle? It is a set measurement, yes. But that's not my question at the moment. We'll talk about what a radian actually is at the moment, but I just want to know how many times can I do. Okay, so I've got the radius, and then I do another radius, and then another. Right, so there's another one. Again, this is not to scale, so do not use this as your guide. Alright, so I've got 3 there. How many times can I go round? I want to hazard a guess. Fact table, how many? How many times? 6? Okay, so the guess is 6 or 4. Or 4. Ladies in the backpack? Ali, stay with us please. 7 times. What about you two in the back? You reckon 7 as well? Yep. What about you guys up the front? 6 or 7? 7.5. Michael's going out on the limb there. So he doesn't listen to the rest of his table. He's got his own answer. What about you guys in the middle here? 6.28. What about you guys? You're going with 6 or 7 as well. Okay, so a couple of votes for that one. Okay, So apart from 7.5, we've got a really unusual guess here. 6.28. Why? M? I know. Why? According to Liam's calculation, yeah?
6.28 equals 2 pi.
Approximately. Why 2 pi? Where'd that come from, Liam?
Because the circumference is 2 pi r, right? And then that's like the distance, and then the radians is the radius compared to the circumference.
Yes.
So if you divide your circumference by your radians, which is r,
Yep.
that just gives you 2 pi.
100% correct. Let's talk about that in a little bit more depth. But he's 100% correct. Okay? So 6.28 is an approximate value. Let's talk about it. Are we all comfortable with the fact that the circumference of a circle formula is 2 pi r? 2 times pi times the radius. What I asked you was, how many times does the radius fit in the circle? So basically I'm taking the circumference and I'm dividing it by the radius to see how many times that happens. Okay? So if I want to know the number of radians, okay, it's going to be the circumference divided by the radius. Because a radian is defined by the arc length of a radial length. 2 pi r divided by r is 2 pi. Okay? Now, what do we know about pi? Yep. So what do we call it? Yes, it's irrational. It's irrational. Okay? It's non-terminating. It's irrational. Okay? We cannot write 2 pi as a fraction. That's what irrational means. Okay? So it doesn't end. So we're going to be getting used to writing numbers in terms of pi. Okay? So we know that a full circle is 2 pi radians. Okay? So how many degrees are there in a full circle? Right. So we know that there are 360 degrees in 2 pi radians. So that's our conversion factor. Right? So here's my question to you. Just so you can picture it. Now, the reason I ask you this question, if I say to you, in your head, imagine a 45-degree angle. Just imagine it. Can you all picture an approximate 45-degree angle? Yeah? What if I said to you, okay, now picture a 90-degree angle? You can all picture that, correct? You've been working with degrees for so long that you can now start to imagine what that's like. It's like if I say to you, imagine a metre. You can all imagine approximately, if I asked you to, you can if you really want to, you can hold your hands out to approximately a metre. Well, how accurate you are is a different issue, but you can get the rough idea, right? If I say to you, how heavy is a kilogram? You can all picture that roughly, a bottle of milk, right? Or something else that weighs a big block of cheese, kilograms. Okay? Okay? The big blocks. Yep. Okay? So, you can picture that. So what we need to do is start to get you comfortable with radians. So you need to be able to picture that. So what I'd like you to do is to have a think about 2 pi radians is 360 degrees. How many degrees is 1 radian? Okay? So you've got a calculator in front of you because there's no way to do it without it. Approximately, and it's going to be approximately because this number is non-terminating. So you're not going to get an exact answer, but approximately, how many degrees is 1 radian? Got an answer, you reckon? Hold on to it. Hold on for a second. I'll ask in a sec. If 360 degrees is 2 pi radians, I want to know how many is 1 radian. We don't use this number ever, by the way. In any calculation, we don't ever use this number that we're working at now. It's just so you can picture about how big it is. Okay, that's all this activity is for. Lita, how big do you reckon? You do. Then I'll go, no, good try though. That's what I'll say. I'm sorry, couldn't hear you. 57.32. So pretty close to 57. You happy with that? Roughly? Who else got that? Because she's right. Oh, you big sucker. How'd you get it, Lita?
360.
Your name's not Lita. Your name's Liam. Yeah? Exactly, 100%. It's ratios. So if 360 is 2 pi and you want to go down to 1, how do I go from 2 pi to 1? Divide both sides by 2 pi. So it's 360 divided by 2 pi. So if you do that in your calculator, you get around about 57 degrees. So can you picture a 57, can you picture 60 degrees in your head? Yeah? Most of you can. Right? 60 degree angle. You can about that. So about that is what 1 radian's equal to. Okay? But as I mentioned, we don't ever use that particular conversion factor. The conversion factor that we do use, okay, and this is the one you need to be familiar with, if 360 degrees is 2 pi, that's a full circle, then we actually end up using 180 degrees is 1 pi. Now, and then we can go from there. So we're going to convert from radians to degrees. Okay? We're going to convert from radians to degrees. For example, if I'm going to convert 60... No, not going to convert 60 radians at all. So let's say I've got pi over 2 radians. Pi over 2 radians. Write down your book how many degrees that is. We know this factor here. We know that 180 degrees is pi. So if I've got pi over 2, how many degrees is that? Okay. Question without notice. Don't answer, but how many of you are struggling to actually know what that even means? What does pi over 2 actually mean? Thank you. I really appreciate your honesty. How many of you in one's boat looking at pi over 2 and going, not really actually sure what that is? Why did I know that? Because this is actually really simple calculation. It's a very, very, very simple calculation. And the reason I did that is because the majority of you are sitting there going, and my problem is because you don't actually know what that means. What's another way of saying, so that says pi over 2, correct? What's the line mean? Divided by 2. So pi divided by 2. What's another way of saying pi divided by 2? Half of pi. So pi over 2 is just another way of saying 1/2 pi. So I could have written that like this. And it's exactly the same thing. However, you'll notice that please notice though, that we are going to write our fractions with the pi in the numerator. Okay? By convention, our pi goes in the numerator. So this is, how many pi's have I got on the numerator? What's the coefficient of pi here? 1. Okay? So it's a 1 pi over 2, which is how we get a 1/2 pi. So now I've written it like that. If 180 degrees is 1 pi, how many degrees is 1/2 a pi? 90. See what I mean by easy calculation? If you understand what the fraction looks like. So that's 90 degrees. Notice also that I've stopped writing the word radian here. Conventionally, there are actually 2 units that we write units for radians. One of them is a little c. You know how degrees is like 60 degrees, you have a little circle at the top, and you know that's the unit for degrees, right? So for radians, the unit for whatever reason, like pi over 2, the unit is actually a little c, although we don't usually write it. It just is. Okay? Sometimes you'll also see pi over 2 rad. Okay? But because we contextualise radians by looking at it as at an angle, if you see pi on 2 and the other ones that we do today, you assume that that must be in radians. Therefore, you don't need to write units. Okay, it's one of those times where mathematicians play on the idea that we're very lazy, we try and use algebra as often as we can, and we don't write a lot. Right? So therefore, we don't worry about our units for radians. So you don't need to write anything. Just be aware, though, that if you see it, little c as a superscript, or the word rad for radian, because it's short for radians, quite obviously. Okay, they can be used, but we don't usually. Okay, so if I know that pi on 2 is 90, what about 2 pi on 3? Yeah. Hang on a sec, just give people a chance to work it out. Hello? Hi. Nope, it's Greg and I've got maths. Yep. It's a B week. Yeah, I don't teach HBA bonds. I know. That's it. Okay. Okay. See you later. Bye. Alright, moving on. Shh. Yes. Yes. Okay, so 2 pi and 3. What's it? How many degrees? 120. How'd you get that?
Well, 2 pi is 360 degrees.
Yeah. Okay, that's true. You can replace the 2 pi with 360 and get 120 and go 360 divided by 3, 120. We are going to look at a conversion factor, a little formula to help us convert, but there are lots of ways of doing it. Okay. The other way you could have done, we know that pi is 180, so 2 times pi, 2 times 180 divided by 3 gives you 120 as well. What about 4 pi and 5? Greg speaking. Hi, Clay. He's already gone. Yep, bye. So 4 pi and 5. So how do we... What's that equal to? Go on. 144? So once again, we can replace the pi with 180. 4 times 180 divided by 5 gives you the number of degrees. Pretty simple. Okay, what if we go the other way? Right, let's go degrees to radians. Okay, so degrees to radians. I'll come and stand this side because it seems to work better. Okay, so this time let's pick a degrees. Okay, let's try 45 degrees. What we're trying to do is come up with a way that we can calculate these efficiently. So 45 degrees, what's that in radians? Just give people a check. What do you reckon, Owen?
Pi over 4.
Owen thinks pi over 4. Do people agree with that? Yeah. Owen, can you tell me how you got it, please?
Well, I know that half of pi is 90 degrees.
Yep.
And 45 degrees is half of 90.
Yep. 45. Yep. 100%. So there's ways and ways. All right. What about? Let me pick a different one. 108 degrees. You may need your calculator for this one. You may not. What do you reckon, Lise? Yeah, you have a go. What do you reckon?
It's like 1.6.
Okay, right. So we try to avoid decimals as often as we can. Sometimes we can't avoid it, but when we can, we don't. So what would it be as a whole, as a complete? It won't be 5 pi over 3, no, because that would be... See, if you think about that, let's have a look at that. 5 pi over 3. Look at the fraction 5 over 3. That's more than 1, right? What's 1 pi is 180. So 5 pi over 3 would be bigger than 180, and we're not there, okay? So that's the other way we can consider whether our answers are right or wrong. That's cool. All right, have another... anyone else want to have a go? Okay, before we do you have an answer, Michael? You don't? That's okay. Let's go back up to our rule here. Oh, so you have a Aaron?
I think I do.
What do you think it is?
2 pi over 3
Okay, that's as ugly as it gets. Do you agree with that? Okay, so if we were going to simplify Aaron's answer, 2 pi over 10 on 3, which would be 6 pi on 10, which is 3 pi on 5. Right? I actually don't know if it's right or not because I haven't actually done the answer to this one. We'll work it out in a sec. All right. What's the matter?
No, it's right. Well, I got what Aaron got. Just, I didn't work it out.
Did you get 2 pi and 3 1/3?
No, I got 3 pi.
Good, that's good. How'd you work it out?
108 divided by 180 to a fraction.
Okay, so let's go back up to here and have a look at this. So we're going to come back to this rule here. Okay, this is our conversion. Not so important when we do radians to degrees because all we do to convert radians to degrees is just replace the pi with 180 and simplify. So the pi comes out, 180 goes in, simplify that answer. Pretty simple. Okay, however, when we're going the other way, not quite as simple. What do we notice is in every answer though? Pi. Right? So the conversion is, if we know the degrees, right? So if I'm going to come from this fact rule here, what's 1 degree equal to? If 180 degrees is equal to pi, what's 1 degree equal to? Beg your pardon? 100%. 1 degree is equal to pi divided by 180. 100% correct. And that's a really important rule. Because if I now have 108 degrees, I'll do it in red. So I've got 108 degrees, I've got 108 lots of pi on 180. Okay, because 1 degree is pi on 80, so 108 degrees is 108 times pi on 180. Using your graphics calculator, 108 pi over 180, ignore the pi part, what's 108 over 180? 3/5. So you use your fraction button in your calculator and simplify. 3 pi over 5. We're going to stop there, obviously, because the bell's gone, but also because we're going to continue this on Monday.